Hey there guys, today we're going to talk about derivatives, what they mean, their representation, different notations, and yeah, so let's get started. Basically the derivative is possibly one of the center ideas of calculus. Calculus is basically the studies of rate of changes, and we're interested in these rates of changes very much. So basically, because the derivative is a rate of change, this is kind of the center of this branch of mathematics. So what is a derivative? So let's say we have an f of x, okay? We'll just say f of x. And this is a function in terms of x. Now, let's say this function, let's just graph it. It will just be an arbitrary function. Let's say it will be something like that, okay? So basically, this right here, our f of x, this is our primary function. Let's say we wanted to know in this function right here, we wanted to know a certain spot in this function and how it was changing. If it was decreasing or if it was increasing, or like what was the function doing at a certain spot in this graph, and how much is it changing. So basically this introduces us to the idea of the derivative. So what is the derivative? Basically the derivative is kind of like the representation of anywhere on this curve, if I was to make a line that was tangent to the curve, like here, or here, or here, or here, I could represent it as, I could represent the slope of that tangent line by the instantaneous rate of change at that point. So, like, let's say here, this is at like, let's say this is at like 2, 3, okay? And let's say up here, this is at, I don't know, 2 or 3, 3. So if we calculate the derivative, if we found a derivative for this function, then we'd be able to calculate the instantaneous rate of change at these points. And what would that mean? That would mean a couple of things, and this will be in later videos. Based on the derivative and what it's equal to, you can tell things as changes in concavity, you know, if a point of inflection takes place. Basically the derivative is just a nice sort of way to, you know, represent what's happening to a function. It's basically a nice little function that you can plug in a number and you can figure out what's happening at that point in the curve. So basically, let's show the notation for the derivative. So I'll show you the different notations for the derivative, and yeah, because, you know, typically we use the Leibniz notation, which is technically dy dx. So what does this say? This says that we have some function y, like let's say we have some function y, and it's equal to something like 5x. So this is saying we're taking the derivative of the function with respect to x, with the function being in terms of y. So basically this says this is your dependent variable and this is your independent variable. So basically, if, you know, let's say I said that that was equal to f of x. So if I did dy dx of f of x, this would equal f prime of x. And this is our first, you know, our first way of representing what a derivative represents. So this would be the first derivative. If, you know, you wanted to take the derivative of this, dy dx, then that would be equal to f11x. So the tick marks represent what order derivative it is. If there's one tick mark, that's first derivative. If there's two, that's the second derivative, and it keeps on going. So yeah, that's basically, you know, Leibniz, you know, Leibniz notation. Now, if people sometimes people like the Newton notation, which basically is, you know, let's say you have a function y, okay, again, y equals, I don't know, let's say x. So if you wanted to find the dy dx of well, let's say that this is equal to f of x. So if we do this in terms of f of x, then this will be equal to y, bam. This is Newton notation. Basically, the dot over your dependent variable represents what order derivative it is. So, you know, if I did something like y and I had 2 dots, that'd be second derivative, 3 dots, third derivative, and so on and so forth. Now, this is rarely used, but I think it's important to show because there's notation called Euler notation. He was a very important mathematical figure. You might know him from Euler's Identity. But typically another way that, and this is kind of similar to the Leibniz notation in theory, basically let's say you had a function y equals 5x or something like that. So if you did dx, okay, y, this would basically be saying take the derivative with respect to x, with y being the dependent variable. And, you know, typically because we denote y as being, you know, like an f of x, this is basically the same as saying this. So yeah, this is Euler notation. Basically we use Leibniz notation the most because it's kind of easier, and you know, it kind of makes a little bit more sense. Especially it makes more sense once you get into things like differential equations and stuff like that. Basically, it's just important to know that the derivative is basically, if I was to draw a tangent line at any point on a curve, okay? So let's say this is our curve. If I was to like draw it here or here, I would get the slope at that point. So if this point was, let's say, this point right here was like, I don't know, like 3, 3, like I could figure out the instantaneous rate of change at this point and figure out how the function is changing exactly at 3, 3. So, you know, obviously here the slope will be 0 and this is a change in concavity, but we'll get there in another video. But basically the derivative is kind of like a function that describes characteristics of its father function. So yeah, I'll leave it at that. Comment and like this video, and yeah, I'll see you next time.